What's up everyone, this is Dariusz Klobaczyk, co-founder of MG Poland, JS Poland, AngularMaster.dev and WorkshopFest.dev. Welcome back to the Angular Master Podcast. Today we've got a special guest straight from the UK. Full-stack software engineer specializing in JavaScript, encompassing Angular, Node, TypeScript and Ionic. Ladies and gentlemen, Matt Lewis. Hi Matt, how are you?
Hey, I'm great, thank you, and I'm excited to be here. How are you?
Thank you, I'm great. So for those who don't know you yet, please tell us about yourself.
Sure thing. So I work on the front-end engineering systems squad at ClickUp. So we do everything related to build tooling, CI/CD, linting, test infrastructure, that kind of thing. I've been on that team for about 2 years now. Before that, I worked for 3 years on the ClickUp product itself, on the Angular front end. And before that, I've been doing Angular front ends for various SaaS startups for about the last 10 years now, ever since the very early days of kind of Angular JS when that first came out. During that time, I've also built a lot of open source projects as well, which was actually how I got interested in build tooling and how I ended up on the team that I am today, where I learned a lot of new things from experimenting with open source and then kind of started bringing those things actually into my day-to-day job.
Is Angular a good choice for a startup?
I think the answer is it depends really. For ClickUp, it was a good choice because a lot of the kind of early decisions were made for you. So like straight out of the box with Angular, you get a strict TypeScript setup immediately. You get a lot of best practices like bundle budgets to help you increase performance. Your decisions about forms, routing, HTTP libraries, etc., are all made for you. So you never have to kind of spend time deliberating and choosing like what library you want to use for those solutions and kind of hoping that that's the best choice and it's still going to be maintained in a few years, whereas the framework just provides it all out of the box for you with Angular. So you can be kind of making really safe bets on the future of your product, because obviously with a startup, you hope that your product's going to be around for a while. So you want to make those bets that are going to be there for long term, and you don't want to invest in a lot of tooling or libraries or whatever that suddenly isn't going to be there or supported in a couple of years' time.
How did your adventure in programming begin?
So I was quite lucky that my high school taught computing. So they kind of gave me some basic education on programming when I was all the way from back to age 16. And from there, I kind of really fell in love with it. I started teaching myself web development and learning HTML, CSS, even jQuery back in those days. And then I started freelancing online. And then I kind of had a bit of a weird moment, like where I ended up co-founding a startup with someone, and we built this product and it kind of really took off, and we ended up with like 100,000 daily active users. And I was still in high school at this time, like kind of managing this project in my spare time. And it really was kind of a baptism of fire where I was the only person writing any code. I didn't really have that much experience because it would still, I only had maybe a year of programming experience. So I had to just learn everything on the fly, everything from managing a database to deploying Nginx, writing all of the front end code. So it was a real kind of fantastic learning experience. And it taught me kind of everything that I have in my career today.
What is the underlying philosophy of Angular that makes it a preferred choice for web developers?
I already touched a little bit about this earlier and about how it's opinionated on how it gives you all of the router forms, CSS solutions, etc. out of the box. And also it gives you the benefit if you can move between companies quite easily with that knowledge. So like when I started at ClickUp, I'd already been using Angular in my previous companies. And from day one, I was able to start contributing code because all I had to really learn was the business logic. I didn't have to spend time figuring out like what router are we using or how do I do forms. It's all kind of, I already knew what those things were doing before I even kind of started working on the code base. The automated upgrades are also a total game changer as well. So the ClickUp code base is enormous. So I think if we didn't have these automated ways of upgrading, it would be really, really difficult, and we'd probably still be on a really old version. Whereas having just a single command to just run all of the upgrade schematics has enabled us to keep up to date with the framework upgrades as they come out every 6 months with new breaking changes. So we're able to give all of our engineers access to the kind of latest and greatest functionality, and we're not stuck on like really old and unsupported versions anymore. It also has a really active community, and it's a really straightforward thing to learn as well. So there's so much content out there to learn Angular. There's loads of blog posts. There's obviously loads of great conferences as well, and tons of other ways to kind of pick up new skills and contribute back to the community. And there's always kind of new people popping up with new ideas, new ways of doing things. And it's really a kind of an exciting community to be part of.
Okay, let's talk about esbuild. So why esbuild is so fast? It's magic, or is there a specific technology behind it?
Sure thing. So there's a lot of reasons why esbuild is such a fast tool. So one of them is that it's written in Go and not using JavaScript. So Go is a compiled language versus JavaScript, which is interpreted. So Go, it's going to compile all of your bundler code in advance, whereas with JavaScript, it's going to have to interpret that on the fly. When you actually start running your bundler, before it can even start bundling your own code, it has to compile itself. So you're going to get some pretty good performance improvements straight off the bat by using a compiled language. Another kind of key feature of Go that makes it really suitable for building a bundler is that you can do things in parallel really, really easily. Unlike with JavaScript, which is single-threaded, obviously you can do things with worker threads, but it's kind of a clunky API. The performance is nowhere near as good or easy to use as you can do it with Go. So that's kind of one of the main reasons that Go can be so fast. Another part as well is that everything in esbuild is written from scratch. So if you compare it to, say, a Webpack TypeScript production application, if you build that using that tool chain, it's going to be quite slow. So initially, you're going to have to parse all of your code with the TypeScript or Babel compiler. You're going to have to compile it, strip the types down level to whatever version of JavaScript you're shipping, and then you stringify that back into JavaScript. Then it gets passed on to Webpack, which will then parse it again. It will compile the code, and then it will stringify that back to JavaScript as well. And then lastly, say you're going to minify it. Again, you're going to have to spend time parsing the code, transforming it, and then stringify it again. So you're doing that parse and stringify step of the code several times over, when really you only have to do it once at the start and once at the end. Basically to parse when you at the very first thing, and then right at the end, you should be spitting out your final JavaScript code. And you should never really have to do it in between. But because JavaScript-based tools typically just do one thing really, really well, and they don't interrupt that well with each other, we kind of have this unfortunate kind of parse, transform, stringify step repeated over again. Whereas with esbuild, it does everything in one tool. So it has this advantage that it will only parse at the beginning, and then it will stringify the code at the end, and it does all the transformations in between, and it's not having to duplicate work over and over again.
How do micro-frontends work, and why should or shouldn't developers adopt them?
Sure. So there's two parts to micro-frontends, really. The first one is kind of the high-level architecture of how you organize your code into distinct units. Or in the case of the ClickUp code base, everything's done into NX libraries. And then once you've divided your code up like that, you assign an owner. So this team owns this feature, and that feature will live inside a library. And this is a migration that we did within ClickUp a few years ago. The application used to be one huge monolithic application. It was just a single Angular CLI powered app. And then kind of by design, it was just a single product, and just one application that was all built and maintained in the same code base. And then we introduced NX, and we divided that application up into, I think it's now hundreds of libraries. And then we were able to, as our team grew from like a tiny startup of 10 engineers or so, to now having, I think we have about 15 teams or even maybe even more. and we assign each team, this team owns these libraries. And then we use the GitHub code owners feature to do that assignment. And then the idea behind that is that we can then allow each team to operate as kind of a mini startup. So we give sensible defaults out of the box, but that team, say they want to switch linter or switch to a different test tool, they have that flexibility to do that within their libraries. And the other part to micro-frontends is having independent deployments and isolation. So this is something we haven't quite yet done at ClickUp. Honestly, it's something I think we probably will do in a few years, but we're trying to avoid it, mainly because of the complexity that it brings. So right now, I think there's only Webpack and maybe Vite has support for module federation, which is the key kind of build tooling part of having independent deployments and this code isolation. So this kind of works under the hood where it will take a single application, but it will actually create separate independent bundles for each part of that application. And then it will iframe those components into each other. So it appears to the end user to be one application, but really under the hood, there's actually multiple different front-end applications bolted together. So then you can even go to the extreme where you can have one of those applications be written in React. That team could own their code in a completely separate repository, deploy on their own deployment lifecycle, but then it would only actually redeploy that single part of the application under the hood. And to the end user, they would be using it, and then only that one part would update when a change was shipped. And then it also prevents the issue of if you have like a common library or something that's shared between a lot of different micro front ends. It prevents a user from kind of changing something that actually breaks a lot of different applications. Instead, each team will be upgrading to that dependency independently, and then they will be shipping that code as and when they choose. So then they won't have someone just break something randomly. But yeah, as I spoke a little bit before, this is something we probably will have to do one day, but we're trying to avoid it just because of the complexity that it brings of kind of having these independent deployment life cycles. Right now, we have like a single kind of release team that handles doing all of our releases on like a weekly cadence. Everything is quite predictable, and that works really well for us right now. But at some point, once we're bigger and we have kind of bigger team sizes and more manpower to kind of manage those things, it's something that we might go down and explore that route.
You're listening, Angular Master Podcast. Listen, code, repeat. Everything you need to know to become an Angular super developer.
Is TypeScript becoming a must-have for modern web development?
Yeah, I think it definitely is. Like, it would be hard for me to imagine starting a project today that wasn't written in TypeScript. It gives you so much in terms of like code quality, avoiding bugs, giving confidence while making kind of large scale refactorings. And it really has been a kind of a game changer in terms of how we build JavaScript based applications today. I think there's still some innovation to be done in the actual build tools themselves. I think we're getting to a place now where kind of transpiling TypeScript, stripping types, down leveling code is actually in a pretty good shape. Like, we've got esbuild, we've got SWC, which is a Rust equivalent, and they're both really fantastic, really, really fast and performant tools. I think the thing that still needs to catch up is the actual type checking itself. For smaller applications, it's not really an issue, but for a large application like the ClickUp app, it's really, really imperformant, and we have a lot of issues there. It's kind of one of our biggest pain points where people will make a change and their IDE will sometimes it can take like 20 or 30 seconds for the kind of errors to actually show up in the IDE because we have so much code in our code base and there's so much work for the type checker to do. And then also it uses like a huge amount of memory as well. I think type checking our application is like 5 gig of memory just to type check things. there's definitely some innovation that is happening in that area. The STC project is quite interesting and worth checking out. This is from the makers of SWC, where they're actually trying to port the TypeScript type checker into Rust. So in theory, this should be a lot faster, use a lot less memory, and it's kind of an interesting project to follow along with. But it's a huge undertaking. Like the counterpart of just stripping types is like quite a relatively trivial thing to do. It's quite an easy transform, whereas a full-blown type checking is a lot more complicated than that. You effectively have to redo all of the work of the TypeScript team over the last 10 years or so, rewrite the whole thing, and keep up to date with changes. So it's going to be interesting to see how that story turns out, but I'm confident that as a community, we'll get there eventually.
What have been your biggest learnings from building a large Angular app at scale?
I think there's two big parts to this. So one of them is to kind of define and stick to really clear, consistent patterns inside of a code base. So as we've been using Angular at ClickUp since V2, I think, there's been a lot of patterns that have evolved over time. So a couple of common ones I can think of is like NGRX. That's gone through multiple different iterations. It's had a number of different best practices. And as we've written new code inside of ClickUp, you can see each of those stages of the NGRX, different best practices of writing reducers or selectors or effects or whatever kind of sprinkled across the code base. And it's the same with things like unsubscribing from observables. There's 4 or 5 different ways I can think of to effectively do take until destroyed, which thankfully now Angular provides an operator out of the box since V16. So it's nice to have a finally approved way of doing that. So all the other ones we can kind of get rid of now. And so the way that we've enforced these kind of coding standards to try and keep things as consistent as possible is with using ESLint rules. So there's a lot of rules out of the box or that you can easily npm install, but we've taken this a step further by actually writing our own custom ESLint rules. And this is one of the things that NX can help with. It has a generator built in where in a single command, you can just scaffold out a new lint rule and start writing code straight away. So we've used this as we're doing code reviews. We'll see common patterns that crop up where we're like, oh, this actually doesn't really meet our coding standards, but actually we could catch this via static analysis. So we've just written a custom ESLint rule for that particular scenario, and we've kind of continuously iterated on this. And now kind of people have those guardrails in place. As soon as they type the code that might not fit our best standards, we have ESLint kind of show up in their editor immediately and tell them about that. So it really helps to shorten the feedback loop there. And it helps our code base kind of stay consistent. And the other kind of big learning that we've had is to just be consistent with state management. So back in the early days of Angular, the only real state management solution out there was NGRX with its global state management solution. This was before the days of like the component store where you had individual component level state management. So naturally, we did what a lot of other people did, and we put everything into the global store, which has kind of become a bit unwieldy as time's gone on. It pretty much broke the Redux dev tools, which is one of the big advantages of NGRX, because we had so much data going into the store that kind of really didn't need to be there. So I think it's important to kind of make those high-level thoughts and architectural changes very early on, very clearly, like make definitions about what should be in the global store and what should be in a component store and when to use each of those two solutions. And yeah, I think that's it.
How do you optimize a large-scale application for performance?
Great question. So there's obviously the straightforward things that you can do that are kind of widely known. So there's split your code up into multiple bundles, lazy load at the routing level, use on-push change detection, that kind of thing. And we've always kind of done those things from day one on the ClickUp code base. But as the code base has grown, we have a lot of functionality. And we had to kind of go one step further, like how do we actually deal with these performance problems at scale to create a really kind of fast and performant application while using Angular. So one of those tools that we've used to kind of take this a step further beyond the kind of defaults that Angular provides you is to use the RX Angular set of libraries. So for people that aren't familiar, the RX Angular libraries give you a alternative set of template rendering directives that you can use as a drop-in replacement for things like ng-for or ng-if. They have a very similar API. It's just called rxif and rx-for. And these have been really, really helpful for improving our actual rendering performance. So you can configure when exactly a component will be rendered on the page. There's different strategies that you can provide to give different priorities. So you can say, okay, component A is the most important thing, and that should be rendered first on the page. And then maybe the sidebar should be kind of deferred and be rendered afterwards. So then the user isn't kind of stuck there waiting on the page while it's locked up, and instead everything will kind of render asynchronously and independently of each other. The other thing that's a big part of our performance optimizations is actually creating tooling and automated reports, which has become a really big part of how we track performance regressions. So we use Datadog's run metrics to monitor kind of real user data for performance regressions. We have performance markers inside of our most popular pages. And then we can actually track and have alerts of, okay, we've done this release. And actually now there's been a noticeable performance regression on this page. So we need to go and investigate that. And we're also using other tools like MemLab is something that was released a year or so ago, I think, from Meta. That's a really great tool for tracking down for tracking down memory leaks. It works kind of framework agnostically, so it works great with Angular. And we kind of have it reporting on all of our main pages, and we just have a daily report so we can see straight away if a memory leak has been introduced. And we've actually used this to find and fix quite a lot of quite bad memory leaks inside of the application that you would never really see from a code review or through reading the code. It's only when you actually have a tool telling you there is a memory leak for these objects on this page that you can actually see where the problem is.
What's a new feature of Angular that you are really excited about?
Yeah, so I think there's been a lot of recent innovations in the framework that have been really, really exciting. So I think there was a time while Ivy was being worked on, well, there wasn't really a huge amount of new innovation going on inside of the framework itself. Whereas like the last few major versions, there's been so much really, really cool progress. Like we have standalone components, we have signals, and then we have like the upcoming control flow sequence inside of templates coming in V17. And I think part of that, I'm really excited by the deferred loading syntax inside of templates, where you'll be able to be inside of an individual template and say, I want to lazy load this part of the template. For example, say you have like a PDF viewer component, which is quite large. You don't want that loading on the page immediately. You kind of want to defer load it to maybe on hover of something, or just defer loading it until the user's idle. So you can show kind of like a spinner while that component's loaded. Whereas before, you wouldn't have really had an easy way to lazy load that. You could only really lazy load at the routing level, but everything inside of that route would have to be loaded kind of immediately. So with this deferred loading syntax, now you can kind of introduce these code splitting points and lazy loading at any point inside of the application. And it's really, really easy to use. It's really straightforward syntax. So yeah, that's really exciting.
What are your thoughts on the adoption of AI in front-end development? Is it a game changer?
I wouldn't go with total game changer, but I think it is a really, really powerful tool. So there's a couple of different applications that I've seen so far of AI in front-end development. I think the most practical one that I've seen is GitHub's Copilot tool. If you're not familiar with that, it's a plugin that you can use for VS Code or WebStorm, and it acts as kind of an AI pair programmer. So as you're typing code, it will give you IntelliSense, and it will look at the context of what you're typing, and it will give you, more often than not, a pretty good kind of prompt of what you're actually trying to type, and it will actually save you a lot of time. So it's quite an interesting tool. Like, so some of the things that it writes, you actually, even though I'm trying to work out how does it know this, like it's actually scarily accurate. Even for kind of more nuanced tools, like if I'm writing an ESLint rule or something, it will actually seem to understand the AST, and it will give really, really accurate prompts for writing out a lint rule, which I would have thought it wouldn't have had that much training data to do. But somehow it's able to know exactly what I'm trying to type there. And it's the same with if I'm writing comments, it will be able to complete that more often than not pretty accurately. And the same with maybe like unit tests as well. There's a scary amount of times where I've sat there and I've normally writing unit tests is quite arduous. And I'm just kind of sat there with GitHub Copilot, just kind of tabbing, and it's just also completing for me, which is really, really cool.
Is there a new tool or technology that you have tried recently that really impressed you?
So at ClickUp, we were stuck on a really old version of NPM as our package manager. And we're like, okay, we need to upgrade here to something more modern. So kind of straight off the bat, we figured, okay, it's going to be latest NPM or Yarn. Those are the two kind of really well-known ones that everyone uses. And then kind of as an afterthought, we added PNPM onto the list of tools we were going to try. And then as soon as we started benchmarking, like PNPM was just winning every single time. Like it was just miles faster than Yarn or NPM. And then when we started digging more into it, we just realized what a really, really awesome tool it was. Like it has a really, really great API. You can customize huge parts of it. So, for example, you could say, okay, I want to override this dependency with another dependency, or maybe I want to hide this deprecation warning, which previously you haven't really been able to do in other package managers. And it's been a really, really great bet. Like since we switched to it, every time we upgrade, we see in the changelog, they're always making it even faster somehow, by like crazy amounts, sometimes like 30-40% faster in like a single change. And it's a really, really great package manager. And if you're not using it yet, I would definitely recommend checking it out.
Can you tell us about how you become interested in open source software and give us some tips for others trying to do the same?
Absolutely. So I got into open source kind of as a spur of the moment thing, really. So way back in the days of Angular 1, we had a requirement in the company I was working for where we had to create a calendar component in Angular that wasn't kind of tied to jQuery as every other component out there was at that time. So I kind of ended up building this calendar from scratch, and kind of as an afterthought, I thought, oh, I'll put it up on GitHub and see what happens. I don't know, but hey, it is what it is. The code wasn't particularly great. I don't think it even had any tests or anything like that. And it was mostly written in a coffee shop over about a couple of afternoons. So I put it out there, didn't really think anything of it. And then all of a sudden, I found people were just filing issues, and people were actually using this project that I'd written in their own companies. So I thought that was pretty neat, and I started responding, adding new features, fixing bugs, and it was kind of a really cool experience. And then when Angular 2 came out, I decided, okay, I'm going to rewrite this thing, going to do it properly now. It's going to actually have tests. It's going to be all in TypeScript, have proper kind of architecture and design decisions made for it. So I rewrote it into this project called Angular Calendar, put that up there. And I think all of the users kind of migrated across from Angular 1. The project kind of started getting much more popular. And this was also kind of at the time where how I got into build tooling as well. So back in those days, there wasn't any Angular CLI. you're pretty much left on your own with configuring your own Webpack config and what have you. So that's how I learned how to build all of this stuff, build and configure all of these tools from scratch. So I started writing custom Webpack configurations to publish the library. I wanted to do code coverage with Karma and TypeScript. At the time, there wasn't actually a way of doing this. So I started another open source project with for doing code coverage with TypeScript.
What kind of person is Matt? How do you see yourself?
Yeah, that's a great question. So I try to be someone that serves others and kind of helps to lift other people up to learn and grow. So I think this is why I actually really like working in the developer productivity space. So I really like kind of solving those pain points of removing kind of the slow or frustrating things in people's day-to-day jobs as they're kind of working on code. So if I can make someone's app compile faster, so they can actually like not waste time just waiting for it to compile, that gives me like a really great degree of satisfaction.
Do you have some hints for us regarding self-organization?
Absolutely. So I don't think I could really get away here without mentioning ClickUp as a product. So this was kind of one of the reasons that ClickUp was created in the first place. So if you're not familiar with it, ClickUp is like an all-in-one productivity tool that you can use from anything from product management to documentation. And we dog food this product internally. So we're all actually using the products kind of day to day that we're building, which is pretty cool. So I use it to keep all of my tasks in one place. So I can see exactly what's the most important problem. And like, this is the top problem that I should be working on. And I should only really focus on that. And then I also use its forms feature as well. So I have this thing I call product management based Slack, where people will message you things and really they're messaging you and there's a work item in there, but it's chat. You're very, very likely to just forget about that. Especially if you've got 2 or 3 other similar requests. So it becomes a bit of a nightmare to kind of manage and track all of that. So now I have a ClickUp form that I just send to people as soon as they come to me with a request like that. And I'm like, go fill out the form. That form then goes into my work list. I can prioritize it. And then it means that I'll never forget about it either.
What about your work-life balance?
Yeah, great question. So this is something that I used to be really terrible at. I was always the guy that was on Slack late at night. I didn't really have very good work-life boundaries. And it's something that I've worked on to improve over the last few years. So I read this book. It's pretty popular, I think. It's called Deep Work by Cal Newport. And there's a load of really, really good kind of ideas and workable solutions that I took away from that. So the most important thing I think that I learned from that was to have like a really, really clear separation between work and the rest of my life. So for example, I deleted all work-related apps on my phone. I don't have GitHub. I don't have Slack on there. Everything is all on my MacBook. So I know that when I finish my day, I can close the lid and consciously say to myself, like, I'm not thinking about work now. I'm separated. I've shut down. Whereas before I used to be constantly distracted by notifications from GitHub or Slack messages or whatever. And I would constantly be drawn back into it. So just having that really clear separation and clear boundaries, it's been really important. And I think as long as you're kind of disciplined with it, you very quickly learn to build the habit. And it's really, really helped me.
Books you would recommend to our listeners?
So it's been out for a long time, but the You Don't Know JS series by Kyle Simpson is really, really fantastic. So I read this quite a few years back now, but it explains so many of those WTF moments of JavaScript where you're doing something and it just does something crazy that you just didn't expect at all. And you have no idea why it is. You kind of hack around it at the time and move on. So when I read these books, it explained pretty much all of those kind of strange moments to me in a really, really simple and straightforward way. And it's a really, really good book series to read. Like I wouldn't recommend it to someone just learning JavaScript, but I think after you've got a year or so of experience, if you read these books, you'll have a lot more context and you'll have run into the issues that they explain. And I think it's been they're a really, really good series to read.
Matt, thank you so much for today's podcast. It was an honor to have you here.
Thank you so much for having me. I really appreciate it.